Hello, in this video we'll build the battery pack for a Jetson robot. Before that, let me introduce you to a tiny motor driver, the TB6612FNG, which we'll be using in this project to control our motors. There are a lot of pins on this board which needs to be connected to the Jetson Nano. I'll explain all the pins in the upcoming video, and we'll also show how to connect and program our nano board to use this motor driver. It's a dual edge bridge, which means that this motor driver has the capabilities to reverse the polarity and hence reverse the motor rotation, and hence we can control both forward and backward rotation of the robot. I'll solder the male buck strips that comes with this board so that we can make it pluggable and we can reuse it in other projects as well. To power up the robot, we'll be using 4 18650 batteries. 2 batteries to power the nano and other 2 to power the motor. Each of these batteries can provide 3.7 volts, and we'll be using a battery pack of 2 series connection, which will make it 7.4 volts. For this project, I'll be using a 4 battery holder. Additionally, to power nano, we'll have to adjust the voltage from battery pack to have 5 volts rather than 7.4 volts. I'll show how we can use a buck converter to step down the voltage as well. Alright, I have this 4 battery holder, and we'll be soldering some wires to the battery holder to make it 2 pairs of batteries connected in series, and one would be to power Jetson Nano and the other would be to power the motor driver. I'll be using this DC jack, which would be the endpoint of my battery, and this fits perfectly in Jetson Nano's DC power jack. I have already soldered the lowermost part of the battery holder, so this is required to make 2 pairs of series, 2 pairs of batteries connected in series. This is how we'll be placing our batteries into the battery pack. This would make a series connection, and we'll get double the voltage from the battery pack, so it would be around 7.4 volts from these 2 batteries. Let us now start soldering the wires to the battery endpoint. output is the buck converter, and this can step down any voltage to whatever we set. So we'll be adjusting the potentiometer to get the output of around 5 volts. I'll be connecting the output from this 5 volt buck converter to the DC jack, the male DC jack, which can be plugged into our Jetson Nano power jack, so as to power it with 5 volts. Alright, I have connected the DC jack to the output pins of the buck converter, and this would plug into our Jetson Nano's power jack. This way we would be able to power Nano with 5 volts. I found this good plastic box which can be used as an enclosure for my buck converter and even the motor driver. We can place the motor driver also inside this box, and the battery pack can sit on top of this. I'm also planning to add a switch and a digital voltmeter so that we know the voltage of the battery pack while powering it to Nano. Also, the switch would help us to power on and power off the battery pack as and when required. So let's do that. Finally, I'm done placing the buck converter, digital voltmeter and the switch for my battery pack, which would be powering Nano, and it perfectly fits inside the enclosure. I have attached the battery holder to the enclosure as well. So this is how it works. In the next video, I'll be showing how to download and flash our Jetson Nano board with the latest L40 build.